Hello everybody, it's Kenneth, and in today's video, I kind of want to explore like vectors, which are kind of crucial for some calculus concepts and are also used in some other areas of math, such as like linear algebra. So while those may sound like advanced concepts, they can also be used in something like high school physics. So, it's not really something to be scared of, and they're not too difficult either, but also we're only going to be going over the basics today. So let's get into it. Well, first, what is a vector? Well, say that we have something that's going 30 miles per hour and it's going in the southeast direction. Well, how could we show that on a graph? Because on a normal graph, maybe we could say that like this is east and this is south, and we would draw a line saying like, oh, okay, well, maybe we show that this is going southeast. But how do we show here then that it's going 30 miles per hour? Well, the way we can show something like this is with a vector. So with a vector, we have the similar thing here. So like south and east. And a vector is sort of like an arrow, right? But you shouldn't think of it like that. But the only reason I say it's an arrow is because you draw an arrowhead on it when you're making one. But really, what a vector is it's a bunch of things that are called directed line segments. So a directed line segment is like this here, except the only difference is that between a vector and a directed line segment, something like this is a directed line segment, but at the same time, the arrow to the right is a different directed line segment. But you can see that the two arrows are the same. They're the same arrow. I literally copied and pasted it. So what does that mean? Well, they may be different directed line segments, but they're the same vector. So basically, these vectors have something called the direction and then the magnitude. Now, for an example here, um, we could draw it like this. Okay, we had this one here. Now, the magnitude would be the 30 miles per hour, and that is the length of the line. So we can write magnitude equals length, sort of. And we can say that the direction, which is southeast, is literally just the direction, right? So now let's bring like a coordinate plane into this. You can't erase that. So I'll go down here. So let's say that we have a vector that goes from points 0, comma 3 to maybe 2, comma 5. So we have a graph here. So 0, comma 3 is going to be here. I guess let's do this in a different color. And 2, comma 5 is going to be up here. So if we have a vector that's going from this point to this point, now this would be called the initial point, because that's where the vector's starting, and this would be called the terminal point, because this is where the vector's ending. So how would that look? Well, it'd look like this. Except imagine that the tip is at the blue point. I know it's a little off. So that's how we sort of draw a vector from 2 points. Now, there's this thing called a unit vector, or yeah. So first, to find the magnitude of a vector, you kind of have to use the distance formula, because you can imagine that this is pretty much just a line, but with an arrowhead. So the distance is going to be the distance formula. Now, what is the distance formula? Well, if you remember, it's the square root of x2 minus x1 squared plus y2 minus y1 squared. Now, in this case, what do we think our x2 is? Well, that would be the x point of the terminal point. So in this case, let's say this is our vector v, denoted with like half arrow on top. Now we could say that the magnitude, which is magnitude is sort of denoted by being or having the vector symbol in two absolute value bars, just so you know. And that's the most common representation you'll see. I didn't create it, so I don't know why that is, but that's just how it is. So using this, we can say the magnitude of our vector is 2 minus 0, which is 2, so squared, plus our 5 minus our 3. So that's also going to be 2 squared, which would be the square root of 8, which equals 2 root 2. Now, how does this tie into the unit vector I mentioned? Well, a unit vector is something that has a magnitude of 1. Okay. Let's just use u for an example here. Now, to get any vector to become a unit vector, you have to first find the magnitude. But you can also do this as a second step. There's kind of two interchangeable steps here. One is going to be find component form. Of vector. And then 2, it's going to be find magnitude. So now we found the magnitude of our vector v. How do we find the component form? Well, the component form is going to be terminal point minus initial point. And what this will do is set it up at the origin. It's going to start the vector at the origin. So for example, in this case, it would be 2 minus 0. So say, and the component form is sort of denoted with this like greater than less than sign here. So you're going to have the x component, which is 2 minus 0, and then the y component, which is 5 minus 3. Now, we can see then that if we do 2 here, so we go up 2, and then we go over 2, I know this isn't to scale, but in reality, these two vectors would be equal in both direction and magnitude. So they're the same vector. Now, with the component form, let's do our 2 comma 2 over here. We can find the unit vector. So the unit vector is going to be the component form, or rather the components, divided by the magnitude of our vector. So for our example, this is going to be our 2 comma 2, and then this is going to be over our square root of 8. And so you'll find that when you use the distance formula for this, you'll get the square root of, and oh, by the way, since this starts at the origin, when you use the distance formula, you'll be doing like 2 over the square root of 8 minus 0. So that's another reason to use component form. So we'll have 2 over the square root of 8 squared, which is just 4 over 8, plus same thing, and then we'll get the square root of 8 over 8, which equals 1. All right, so you'll see that that is what a unit vector is. The magnitude equals 1. Now, last thing I sort of want to talk about is the like standard units for things. So if you have a vector that's going in the x direction, it can be denoted with a I, and then the vector symbol. So say we have a vector that's like 3i. What does this mean? Well, this means that, let's say this is 3 out here. Terrible scale, I know. But then that vector would be like this, okay? No y-axis movement, just straight to the right. Now, say that we have something for the y, right? Well, what would it be for y then? Well, y is going to be denoted by j. So say we have something that's like 2j, right? What does that give us? Well, that would give us a vector like this. Now, there are unit vectors for these, right? Like just I by itself is a unit vector because it'd be kind of like this. And then j by itself is a unit vector. And then If you get into 3 dimensions, which is a little more advanced, you have k, and k is for the z direction, which if you don't know is like upwards, right? So in 3 dimensions, you have like the 2D plane and then out like this, and this is z. So z, x, and y. Now, so this will be with like k, and then as we said, this is with j, no, the I, sorry, with I, that still looks like a j. And then this is going to be with j. So that's really it for this video, and I hope you guys enjoyed, but that's all I have. Thank you.